Okay, so you guys are going to like this way better. This is way easier than negative exponents. Okay? No joke, way easier. Okay, so when we're dealing with properties of exponents, you guys, I'm not going to have you evaluating them. Okay, so that's the kind of nice part. We're not going to evaluate anything. What we're going to end up doing is writing it as 1 power. Okay, and I'll show you what that means. So in your notes, if you haven't written a header already of properties of exponents, there's a few things you're going to write down, and anything you write down, you're going to be able to use on the test. Okay, when we get to the test, you get to use your notes. So if you write this down, you'll get to use it. Okay, so the very first property we're going to talk about is called product of powers. Okay, so I want you to write this, product of powers. Now, don't worry about writing everything else yet. Just put that. Okay. Now, I'm going to show you a couple of examples, and I think you guys will be able to come up with the rule. Okay. So product means multiply. Okay, and multiplying powers. So 6 times 6 times 6 times 6. If I wanted to write that just with an exponent, okay, that means it would be 6 to the 4th power. Give me a thumbs up if you agree with that. Okay, that's 6 4 times, it's 6 to the 4th power. Okay, now if I look at this second example here, it's 6 times 6 times 6, which would be 6 to the 3rd power times 6 to the 1st power. Well, ultimately, we're still doing 6 4 times. So it's still 6 to the 4th power. Okay, and the third example has 6 to the 2nd power times 6 to the 2nd power, which ultimately is still 6 to the 4th power. Does anybody see a pattern of how I get this final answer each time? A rule that we could write down? Okay, so I want you to put this in your notes. Multiplying powers with the same base. Okay, now the key here is that they have to have the same base number. So when we're multiplying powers with the same base, you're going to keep the base and add the exponents. Okay, so take a minute, write that in your notes, because remember, this is going to be helpful to you. If you're multiplying powers with the same base, keep the base, add the exponents. Okay, so you're going to see problems on your homework today that look like this. 6 to the 2nd power times 6 to the 4th power. Okay, so if you were going to put an example in your notes, I'd write this down. 6 to the 2nd power times 6 to the 4th power. Now, the base number's the same. They're both 6's. And if I'm asking you to write it as 1 power, yes, Hannah, go ahead. You're just going to add the exponents. So you're going to keep the base and add the exponents. 2 plus 4 is 6. So it's 6 to the 6th power. Okay? Now, if it's, let's say, 5 to the 4th power times 5 to the negative 1st power. Okay, now again, it's the same base, so we're going to keep the base, and we're going to add the exponents. 4 plus negative 1 is 3. So it'd be 5 to the third power. Okay, so let's try a few more examples. Let's start here. And can you guys do me a favor and just be willing to unmute yourself if you know the answer? That's easier than typing it in the chat. Okay, 3 to the 5th power times 3 to the 2nd power. I don't want you to evaluate it. I just want you to come up with the answer as 1 power.
3/7.
Yeah, 3 to the 7th power. Okay, so if you want to write these down in your notes, you can write examples. This would be 3 to the 7th because you're taking the exponents and you're adding them. 5 plus 2 is 7. Okay, how about 1/2 to the 4th times 1/2 to the 5th?
1/2 to the 9th.
1/2 to the 9th. Because 4 plus 5 is 9. Okay, the next one. Write this next one in your notes because I want you to notice something on this one. So it says 7 times 7 to the negative 8th power. Now notice the 7 doesn't have an exponent listed. What's the exponent on the 7 when you don't see one?
0.
It's not 0.
1.
1. So you guys, when you don't see a number as an exponent, you can put a 1 there. So I'm going to put 7 to the 1st power times 7 to the negative 8th. Then we keep the base and add 1 plus negative 8. So it's going to be 7 to the negative 7th power. And you can leave your answer just like that. All I'm asking you today is to write them as 1 power. Okay? Questions there? Okay, let's look at a couple more. Look at this next one. What do you notice about this next one? Anybody notice anything?
There's letters.
Okay, let's look at this one right here, though. This one right here does not have letters.
The numbers aren't the same.
The numbers aren't the same. The bases aren't the same. So we can't do anything if the bases aren't the same. So on your homework, if you see something like this where these numbers do not match, this is what you're going to write. Cannot combine. I cannot do that. I cannot combine those. I cannot simplify it because the bases are not the same. Okay? Now on the next one, yes, there's letters, but it doesn't change what we do. I have an X and an X. The bases match, so it's going to be X to the add the exponents. 3 plus 2 is 5. So X to the 5th power. Okay, the last one, what would you say?
Cannot combine.
Absolutely, you cannot combine that. Okay, the bases are not the same, so we cannot combine. Okay, that's the first set of rules. We've got 2 more sets of rules to go through. Okay, here's the next one. The next one is quotient of powers, or dividing powers with the same base. So you can start by writing this in your notes. Dividing powers with the same base. So we did multiplying powers with the same base. Now we're going to look at dividing. Okay. Okay, so let me show you what happens here. If we're going to do 5 to the 5th power divided by 5 to the 3rd power. Okay, now what this really means would be 5 times 5 times 5 times 5 times 5 divided by 5 times 5 times 5. Okay, and we know that we can then simplify. Okay, so I notice that in the top and the bottom, this is just a fraction. I can simplify a 5 and a 5 to a 1 and a 1. And I can simplify those, and I can simplify those. So what I then end up with is just 5 times 5, which is 5 to the second power. So what's the quick way then to get from here to here? What do you think the rule is?
Subtract the exponents.
Yeah, absolutely. So if the bases are the same, key being they have to be the same base, but if they're the same, keep the base and subtract the exponent. So keep the base, subtract the exponents. Okay, so these problems are going to look more like this. We might have 4 to the third power over 4 to the second power. Again, the bases are the same, and we just subtract 3 minus 2. So it'd be 4 to the first power. Okay, questions there? Let's try a few examples. And again, you can put any of these in your notes as examples to look back at. Okay, let's start with number 1 here. 10 to the 9th power over 10 to the 3rd power. If I had to write it as 1 power, anybody willing to unmute themselves?
10 to the 6th.
Absolutely. You're just doing 9 minus 3, so it's 10 to the 6th power. Okay, how about the second one? 4 to the 5th over 4 to the 2nd.
Four to the third power.
Good, 4 to the 3rd. Again, the bases were the same, so we're doing 5 minus 2. Okay, here's where you have to be careful. How about the third one? -12 to the 1st over 12 to the 4th.
-3.
Yeah. So because this number is 1 and we're doing 1 minus 4, right? 1 minus 4 is -3, so it's 12 to the -3rd power. So be careful, you might still get negative numbers. Be careful with your subtracting. Okay? How about number 4? Anybody want to take a guess at what number 4 would be?
-3 over -3.
Careful. So it's not -3 to the -3rd power.
-3 to the positive third power.
Not positive third either. So you guys, this is where we have to be really careful with our negatives, right? We know the base number is the same, so it's going to be -3 to some power, okay? Now, I have to do 7. Whoa. Let's try that again. 7 minus -4. What's 7 minus -4?
11.
11, right? Keep, change, change. Don't forget about that. We would do keep, change, change. So 7 plus 4 is 11. So this is -3 to the 11th power. Okay, so just be careful with negative signs. Okay, how about the fifth one here? N to the sixth power over n to the second power. That would be n. And then you have to do 6 minus 2, which would be n to the fourth power. Okay, and the last one, what do you notice on that one?
Cannot combine.
Cannot combine, right? The bases are different. We have a y and we have an x. And since they're not the same, we would say we cannot combine. Okay? Questions on that rule? So if you're dividing, you subtract the exponents, but the bases have to be the same. Okay, the last rule is raising a power to a power. Okay, so you can write this in your notes, raising a power to a power. Okay, so I'm going to explain it first and then see if you guys can come up with the rule. Okay, these problems are going to look like this, where we have 4 to the third power, so a power raised to the second power. So a power raised to a power. And what that really means is this 2 tells me I need this 2 times. So it's 4 to the third power times 4 to the third power. Well, if I were to write that out, that's 4 times 4 times 4 times 4 times 4 times 4, which then is really just 4 to the sixth power. So can anybody tell me what the shortcut is to get from here to here? What would the shortcut be?
Just use the multiplication rule.
Yeah, just multiply. Okay? So if you're raising a power to a power, keep the base. And multiply the exponents. So keep the base, multiply the exponents. I'll give you a second to write that down. And then we'll do a few examples, and then we'll be done. Okay, so if you want to put one example in your notes, these are going to be problems that look like this. 3 to the fourth power to the third power. Okay, you keep the base, and you're just going to multiply the exponents. 4 times 3 is 12. Okay, it could be 4 to the third power to the negative second power. Again, keep the base, multiply the exponents. 3 times negative 2 is negative 6. So it ends up being 4 to the negative sixth power. Okay, so you guys unmute yourself and tell me what would this first one be? 7 to the fifth power to the third power. If I were to simplify that, what would that be?
7 to the 15th power.
Absolutely. 7 to the 15th power. And we don't want to evaluate that because that's a really big number that won't even fit on our calculator. So we're just writing it as one power. 7 to the 15th power. Done. Okay, number 2, what would that be?
2 to the 14th power.
Absolutely. Okay, we keep the base, -7 times -2 is positive 14. So 2 to the 14th power. Done. Okay, 2 more problems. Number 3 here. 8 to the 9th power to the 11th power. What would that be?
8 to the 99th power.
8 to the 99th power. 9 times 11 is 99. There's our answer. Okay, 12 to the 10th power to the -6th power. It's going to be what?
Twelve to the -60th power.
Absolutely, 12 to the -60th power. 10 times -6 is -60. Hey, what if I gave you this one? 5 to the 7th power to the 0 power. What would that be?
One.
1, right? So I would accept either of these answers. You could either write 5 to the 0 power or 1. Because remember, anything to the 0 power is 1. Okay, questions there at all?